Hello, this is a review video for you to help you get ready for your Chapter 3 test. So problem number 1 on the review looks like this. Y equals parentheses x minus 8 squared minus 1. And first of all, let's just remember what that means. What that is a parabola that is shifted right 8 units. 1, 2, 3, 4, 5, 6, 7, 8. 8 units to the right, and also 1 unit down. So the parabola starts right there, and then because the squared term, the front of it is positive, that's a positive term right there, it opens up. So it opens up like this. And that's all we need to know in order to answer this question. So whatever your problem does, just imagine how the graph of it looks, and then you'll be able to answer the question. So first of all, the question says, what is the range? The range is the bottom y value of the function, which is -1, through the top of the function, the highest y value of the function. And this function never ends, it goes up forever. So the top of the function is at infinity. And then since it does touch a y value of -1, there's going to be a bracket on that side, but it can't actually touch infinity, so there's a parenthesis on that side. Then it says, what's the minimum value of the function? The minimum value of the function is the lowest y value, which is -1. And then it says, when is the function increasing? Well, increasing, you look at the picture from left to right. And that part right there is the only part that's increasing from left to right. And now left to right means you look at that x value and then this x value at the other end. Well, the first x value is at 8. But the thing is there's not really an x value at the right side of that arrow, because the arrow continues going forever. So the right side of that increasing part is actually infinity. So it's going to increase from 8 to infinity with a parenthesis. And then now let's find out when it's decreasing. So decreasing, you look at it from left to right and you figure out where it's going down. So it's going from left to right, it's going down right there. And you look at the left side of that. Well, there's not really a left side of that, because the left side of that is an arrow that continues forever. So the left side of that decreasing part is actually -infinity. The right side of the decreasing part is 8, and it touches 8, so we're going to put a bracket on that side. But there's a parenthesis beside the -infinity. So those are the 4 answers to problem number 1. Now let's look at a review for problem number 2. So problem number 2, it says y equals -4 x minus 2 squared plus 16. And so once again, let's imagine this graph. So this graph moves 2 units to the right because of that -2, and then it moves 16 units up. So 2 units to the right, 2 units to the right would be there. Then it moves 16 units up, which would be right there. So it's going to equal that point. But then it's the sign in front of this is a negative sign. In front of this squared part, it's a negative sign in front. So that means it opens downwards. So this parabola opens downwards, like this. Now, we need to find the axis of symmetry. Well, the axis of symmetry is right where that dot is. It's the line that goes through the middle of that dot at the top or the bottom. So that's the axis of symmetry, which is vertical. So the axis of symmetry is the equation that's vertical, so it starts with an x. It's x equals 2, like that. And then next it says find the y-intercept. So the y-intercept is when you plug in 0 for x. So if you plug in 0 for x, you'll get negative 4 times 0 minus 2 squared plus 16, which is negative 4 times 4 plus 16, which is negative 16 plus 16, which is 0. So the y-intercept is the point x equals 0, y equals 0. So it's an ordered pair, 0, 0. Now, the notice that a parabola is always symmetric. So this side right here is 2 units to the left of this. This one is 2 units to the right of that. And so that means you actually can tell that the other side is going to be 0 at the same distance from the center of the graph. So if you know that there's a point that touches the x-axis 2 units to the left of the middle of the parabola, then there's also a point that touches the x-axis 2 units to the right of the middle of the parabola. And this one would be 4, and this one would be 0. So the next question is, what are the x-intercepts? Well, the x-intercepts, we have to write them as an ordered pair. The first one would be 0, 0, and then the next one would be 4, 0. And then it says, what direction does it open? Well, because of that negative sign that I pointed to earlier, because of that negative sign, it opens down. So this parabola opens downward, like that. All right, now let's look at problem 3. So x squared minus 4x minus 12 greater than or equal to 0. So factor it out. Actually, yes, let's factor this out. So it'd be x, x, x. And then if you break apart the negative 12 into two numbers, we could either get 3 and 4 or 2 and 6, as well as maybe some other ones, like 1 and 12. But I'm going to use a negative 6 and a positive 2, because negative 6 plus positive 2 equals negative 4, which is the number in the middle of the problem. Now I'm going to make a quick graph of this. So they already show a graph to you on the problem, but I'm going to make another one though. So if you look at the problem, x equals 6 is an x-intercept. X equals negative 2 is another x-intercept. So what happens is, and the x squared term is positive, so the parabola opens upwards like this. And then, sorry, I accidentally wrote something there. Okay, and then now look closely at the problem. You see it said greater than or equal to 0. So the parts that are equal to 0, they're good. We want them to equal 0, right? So let's color those yellow, fill those in with yellow. And then also, the part that is greater than 0 is also going to be true. So fill the part that's greater than 0 with yellow. But the part that's below 0, we don't want that part, right? We don't want any of that part that's below 0. So the answer to this problem is the part that's shaded in yellow from left to right. So it's going to be, the left side actually is negative infinity because it has an arrow that goes forever. And then comma, and then -2, and it touches the dot, so it's going to be a bracket. And then there's a gap, so put a union. Then it touches 6, so put another bracket. Then it goes to infinity. So there we go. So that's the solution to this problem. And you can actually just look at the picture to find the solution to it, because on your question, it already shows you the picture. All right, now, number 4. Okay, so what you can do on this one is multiply the 2 and the -9 together. They call that A and C. So A times C equals 2 times -9 equals -18. Then you break that apart into something that is that factors of -18 and that add up to be -7. So we could do, let's see, -9 and +2. So then what you do is you write those two factors in parentheses, and then you write the 2x squared in the beginning, except you get rid of this square, but you don't get rid of the 2. Now you eliminate any common factors, like there's a 2 in common. So eliminate that. Then you'll have 2x minus 9, and you'll have x plus 1. And then you'll have less than 0. So if I solve this equation and find out when this is 0, you'll get 2x minus 9 equals 0 and x plus 1 equals 0. So you'll get, if you add 9 to the other side, you'll get 2x equals 9. If you add -1 to the other side, you'll get x equals -1. Then divide by 2, you'll get x equals 9/2. Then you have x equals -1. Now those are the x-intercepts. So we're going to make a graph like this and put 9/2 onto the graph and put a dot there. That's equal to 0. Then put -1 onto the graph and put a dot there. That's equal to 0. Then, now you look at the number that's in front of this square and see if it's a positive or a negative. That's a positive, right? So we know that this is a parabola that opens upwards. So the graph of it looks like this. Halfway between those 2 points is the middle of the parabola, and then it opens upwards through both of the ends. And now we'll find the part that's less than 0. So you see this part down here is less than 0. So we'll shade that. This part up here is greater than 0, so we'll cross that out. And then what about the 2 points that are actually 0? Well, it has to be less than 0, not actually 0. So it can't be 0. So let's put an x through the 2 x-intercepts, because it can't actually equal 0. So the only solution to this is between -1 and +9/2. And it can't equal the numbers on either side. So it's going to have parentheses around both of them. So there we go. Now, problem 5. Actually, just a second. I forgot. There's one more part on problem 4. I just forgot about it. We have to make a number line. So the number line goes from -1 through 9/2, and you fill in the middle part, and you put parentheses around both ends of it, because it cannot actually touch -1, and it cannot actually touch 9/2. And 9/2, by the way, is 2 goes into 9 4 times and 1/2 left. So it'd be 4.5. So look for the graph that goes from -1 up to 4.5. And it has parentheses on both sides. Okay, now let's do number 5. So the football height is equal to the formula -16t² plus 64t plus 4. Then we need to find the maximum height. Well, there's a really cool formula called the vertex formula. It's just negative b over 2a. So it's negative, and then over 2. The question is, what's the b and what's the a? This number is called b, 64. And then this number at the front is called a, negative 16. So we'll get negative 6, sorry, looking at the wrong number. We'll get negative 64 over negative 32, which equals positive 2. And then to find the height, we'll plug in 2 into the height formula. Or negative 16 times 2 squared plus 64 times 2 plus 4. That equals negative 16 times 4 plus 128 plus 4, which equals negative 64 plus 128 plus 4, which equals 64 plus 4, which equals 68. So 68 feet high is how high the football goes at the highest. Now, let's try problem 6. So the fuel is equal to the miles per pound of fuel is m equals negative 0.000654 a squared plus 0.129 a minus 5.06. And so we're going to look at the graph and figure out, so the graph looks like this. Figure out the most miles that you can get, the most economical airspeed. So this graph shows the miles that you can fly per pound of fuel. So obviously you want to fly the most miles per pound of fuel. That means we have to find the vertex of this graph of the fuel miles per pound of fuel versus airspeed. So we're going to use the same formula again, because to find the vertex of a quadratic function, you can use the formula negative b over 2a. So it's negative b, and b is 0.129, divided by 2 times a, which is negative 0.000654. So if you do that on your calculator, you'll end up with about 98.62. Wow, 98.6, isn't that like the normal temperature? Something like that. So now what we need to do is, actually, I forgot something. What I did is I actually did the answer to part B first. So that's the answer to part B. The answer to part A is to just look at the picture and you just estimate. So it's like 60, 80, and then like 100, 120, like that. So according to the graph, the best point would be about 100 miles per hour, right? Because that's the closest value on the x-axis to the highest point of the graph. So the answer to part A is actually just 100 miles per hour. So whatever is the closest to what the graph shows on the x value that's near the high point of the graph. But then in part B, that's when you do the formula to find the exact value of the airspeed that maximizes the miles per pound of fuel. Now, next of all, Next, it says, if the aircraft was flown at 99 miles per hour and got 1.30 miles per pound of fuel, which weighed 6.17 pounds per gallon, the number of gallons that would have been needed would be how many gallons per hour? So basically, we know that this plane gets so this is part C. It gets 1.30 miles per pound of fuel, right? So in 1 pound of fuel, you get 1.30 miles. And then the fuel weighs 6.17 pounds per gallon, right? Wow, okay, cool. So it would be 6.17 pounds for 1 gallon of fuel, right? So that means that if we cross out the units of pounds, sorry, I meant to cross them out, not erase them. If we cross out the units of pounds, then you're left with miles on top and gallons on the bottom. So 1.30 times 6.17 is how many miles you get per gallon. But then we need to figure out how many gallons you get per hour, right? So it's being flown at 99 miles per hour, right? So it's 99 miles flown in 1 hour, right? So if you put miles in the bottom, then that unit crosses out the miles that's in the top. So then you get how many hours per gallon you have. So let's calculate that real quick. So where is my calculator? Okay, so 1.3 times 6.17 times 1. So on top I get 8. I get 8.021 hours, right, on top. And the bottom I have 1 times 99. And then the bottom, the only unit is gallons. So there's 8.021 hours per gallon. Now if I flip that over, I'll get gallons per hour. So if I flip it over, I'll have 99 gallons in 8.021 hours. And then 99 divided by 8.021 is equal to 12.34, approximately 12.34. And that would be gallons per hour. So when you're flying the airplane at that speed of 99 miles per hour, it would use about 12.34 gallons of fuel every hour. Perfect. Now let's try problem 7. So problem 7 says, check to see if the given 0, and then it gives you a number. Check to see if that, I'm going to put a little box around it. Check to see if that is a 0 of the polynomial function 3x cubed plus 8x squared minus 5x minus 8. So what you do is you take the given number, the -3, and then you take the coefficients of the polynomial and you write those down after that number. So 3, 8, -5, and -8. Now you have to be careful if there's anything missing, like let's say if you didn't have any 8x squared, then you'd have to put 0 there instead of 8. So if you have any power of x that's missing from your polynomial, you have to think of that as having 0. Then the process of synthetic division starts by bringing down the first number. Then you multiply this number together. -3 times -3 times +3 is -9. Then you just add those up and bring them down. So be -1. Then you multiply positive 3, then you add, then you multiply, 6, and then you add, so negative 2. And so if you get 0, then the answer is yes, it's a 0. If you don't get 0, then the answer is no, it's not a 0. So the answer in this case would be no. It is not a 0 that we get. All right, now let's try problem 8. So this one says 22x to the third minus 34x squared plus 42x minus 21. Find all possible rational zeros. So the possible rational zeros are equal to factors of the constant 21. The factors of 21 are 21, let's see, 11, 10, 9, 8, 7, right? 3 and 1. Factors of 21. And then you divide those by the factors of the leading coefficient, which is 22. So what are the factors of 22? It'd be 22, 11, 2, and 1. And they could be positives or negatives. So it could be positive or negative of any of those numbers. So what you do, this is a multiple choice question. So what you do is you look for the answer that lists all the possible combinations of those numbers. So that means it will have, like, for example, 21 over 1, which is be 21, or 21 over 2, or 21 over 11, or 21 over 22, right? So it could be any of those 4 answers. Then it could also be 7 over 22, or it could be 3 over 11, or 3 over 22, or it could be 1 over 22. Or it could be, so basically it could be 4 different numbers over 22, or 4 different numbers over 11, or 4 different numbers over 2, or 4 different numbers over 1. So there's a lot of combinations that it could be. So pick the answer that lists all those possible combinations. Okay, let's try number 9. So number 9 says x to the 4th plus 2x cubed minus x squared minus 4x minus 2. So first of all, we need to use synthetic division to try to find one of the answers. Now, if you think about it carefully, it's a good idea to try to plug in -1 or +1 in your head, because often they would work. So if I plug in 1 in my head, I would end up with 3 minus 7. So that does not equal 0. So let me try to plug in -1 in my head. If I plug -1 in my head, I get +1 minus 2 minus 1 plus 4 minus 2. And that one adds up to be 0. So I know that -1 will work. So what you do is you do synthetic division, starting with -1, because you know that's going to make the answer be 0. So now write down the coefficients of the polynomial. There's an invisible 1 right there. So it's 1, 2, -1, -4, -2. Then you leave a blank space, bring down the 1, then multiply it by the -1. Then you add this up. Sorry. 2 plus -1 is really just 1. 1 times -1 is -1, then add them up. Then multiply by the -1 at the front and you get +2. Add those up, multiply by that, and you get +2. Then you get 0. There we go. Now, you might as well try dividing by -1 again. So I'm going to do that again. Leave a blank space. Bring down that one. Now 1 times -1 is -1. That adds up to 0. 0 times that is 0. That adds up to -2. -2 times -1 is +2. And then that adds up to 0. And then here you have that. Now what you have now is every time you finish in synthetic division, and if you get 0 at the end, that means the power goes down by 1. So it used to be 4th power, then it'd be 3rd power. But now we've done it twice. It's only going to be the 3rd power. the second power. So this represents 1x to the second. The 0 in the middle represents a missing x, like 0x, right? And then this number is just a -2 by itself. So what I'm going to do is I'm going to set that equation up and then solve it by itself. And the 0x doesn't really matter, so I'll erase it. Then I'll move the -2 to the right side. So we got x squared equals +2. Then I'll take the square root of both sides. But remember, when you cancel out a square, you have to do a plus and minus on the other side. So x equals plus or minus square root of 2. So the answers of the problem would be -1, because that's the first answer that I figured out in my head, -1, and then square root of 2, and then negative square root of 2. So there's 3 answers total to this problem. Now, one of the answers does actually happen twice. -1 actually happens twice. Later on, we'll learn what that means if you have an answer that happens more than once. All right, now, problem 10. This says -t to the 4th plus 12t to the 3rd minus 69t to the 2nd plus 198t. So then it shows you a graph. And the graph is a parabola that starts from 0 and then goes up and comes down. Now notice it hits the bottom 0 when it's 6. So this concentration of the drug goes into your bloodstream at the beginning. Times 0 represents the beginning. And then you start counting after that. After 6 hours after that, then the drug will be gone from your blood. So it'll be totally eliminated in 6 hours. That's the first answer. And then the maximum concentration of the drug. So you look at the graph really carefully, and this is super hard, you know. Okay, so this says about 220, and this says about 200. Now, this graph on my page, the 200 is actually a tiny, tiny bit above the top of the graph, right? So it's more than 210, right? On my graph, at least. On my graph, it's more than 210, but less than 220. And it's a tiny bit more than halfway between 210. Sorry. It's a little bit more than halfway between 210 and 220. So my guess would be that the highest point of the highest concentration of the drug is about 216. That'd be my guess. And then how many hours does that happen? Well, remember, if you have a parabola, the midpoint is halfway between the two x-intercepts. So that would happen after about 3 hours, right? Because 3 is halfway between 0 and 6. And then the approximate time for it to, so 140. So then it asks us something about, oh wait. So yeah, so part C, the answer to part C is 3 hours. Then part D, how long is the concentration above 140? So 140 on my graph, it goes 120, and then 140 would be like right about there. It doesn't actually show 140 on my graph, but it's like halfway between 120 and it shows 160 on my graph. But then 120 and then 140. So 140 would be halfway between 160 and 120. Then it says, how long is it above 140? So if you look at the line 140, how long does it stay above 140? Well, on my graph, this point is exactly at 1. This point over there is exactly at 5. So on my graph, between hour number 1 and hour number 5, the graph is above 140, right? From hour number 1 to hour number 5. So that means that for how many hours is it from hour 1 to hour 5? That's 4 hours total, right? So for 4 hours, the concentration is above 140. So that's number 10. Perfect. Now let's try number 11. So 9i and negative 9i. So whenever there's a pair of numbers with I in them, that represents an equation that has x. So actually it represents two equations. It represents x equals 9i and x equals negative 9i. Now we're going to solve this problem backwards. We're going to move the 9i to the left. Then we'll move that negative 9i to the left, like that. Now those two equations represent two separate factors, but now I'm going to bring those factors back together. And then now I'm going to multiply those factors together. So because those are the same values, the same two values, but they just have opposite signs between them, they are called conjugates. So when you multiply conjugates together, you only have to multiply the first part and then the last part. And then we now know that I squared equals negative 1. So what's negative 1 times negative 81? That would be positive 81. So the equation that represents the solutions, the roots, or the answers, negative 9i and positive 9i, the equation that represents them is actually this. So your answer is the equation. So in problem 11, you're working backwards from an answer to an equation. So it's important to be able to convert values like those numbers into an equation. All right, now let's try number 12. So let's use Descartes' rule of signs. So first, let's look at the first pair of terms. Are those the same sign or different signs? They're the same. Now let's look at the next two, the same. The next two, the same. So every single pair of things is the same. So there is never any change in signs, right? So how many changes in signs are there in this problem? There's none. So there's 0 changes in signs of f of x, right? Sorry. 0 changes in signs of f of x. So that means there's zero positive real roots to this problem. Now we find f of negative x. We find f of negative x, which if you plug a negative x into it, the odd powers become negatives. So it's negative x cubed. The even powers stay the same as they were, but the odd number ones become the opposite. Now count the changes in signs. There is one change in signs, that's a change in signs, and that's a change in signs. So there's 3 changes in signs. So there could be 3 negative real roots, or now sometimes within that number 3, 2 of them could be imaginary. So it's possible that you have only 1 negative actual real root, but then you have 2 imaginary roots. So you could have 3 negative real roots, that's a possibility, or you could also have just one negative real root and 2 imaginary roots. So Descartes' rule of signs says that you count the changes in signs of f of x. The number of changes in signs of f of x is equal to the number of positive real roots, or it's equal to the number of positive real roots combined together with pairs of imaginary roots. And then Then you look at f of negative x, and you count the changes in signs. And the number of changes in signs is either equal to the number of negative real roots, or it's equal to the number of negative real roots combined together with the number of imaginary roots. And the number of imaginary roots always has to be an even number if you have a polynomial that has real coefficients. All right, well, I'm going to make another review for you again after this later on, starting with problem number 13.